so that I actually finish this, I'm going to type it up. So we had string versus array list string. We had a equals new string 10 versus a equals new array list string, and then the parentheses behind it. We had, so that's what we had. And then I said, oh, you can also do this another way. You can over here omit the string inside, but you still have to put in the angle brackets. And in this case, it is going to look at the left-hand side and say, oh, this was an array list of string, so therefore surely they want to construct an array list of string. If you like this shortcut, go ahead and use it. The textbook doesn't use it, but it's just there. It's a fairly new thing, and so probably people will get used to it. All right, now how do you get stuff into an array? You say a bracket I equals x, or to get it out, you say x equals a bracket I. Then with an array list, you would say a dot set I comma x, and x equals. If you want to loop over it, you would say for I equals 0, I equals a dot length, I plus plus. And over here, you say for I less than a dot size. And otherwise, it's the same thing. So what I want to get across is that arrays and array lists are really the same thing, two different syntaxes. The only difference is that with array lists, you can add and remove. So with array lists, if you want to add an element at the end, it's very easy. You say a.add, Fred. If you want to say remove the first element, you say a.remove 0. For arrays, not so much. So there's no good way of doing the same thing with arrays. So, so that's the basic logic here. So what you just need to keep in mind is that arrays are containers, array lists are containers. You can get at the ith slot, you can read it, you can write it, you can traverse the array with a loop where you go, just like with strings, from the beginning until the end, not quite until the end, increment every time. And so that's enough to do the homework. But now I want to talk a little bit more about the iteration thing. So we have it over here and here, where it's the same for loop. And that for loop is basically fine. That for loop is basically fine. So let's say I want to compute the sum of, let's say I want to print everything that's in an array. And let's say it's an array of strings. So string. I get the ith value out. This is kind of similar to what I've done before. I had a string and I would get the ith character out. And now I process the thing. And here I'll just print it. All right. Oops. What did I do wrong?
What if for if the for loop is not, or wait, no. It's,
So with a for loop, I think it's okay because it goes from 0 and it goes less than.
right. So
And it has
it'll
plus
just,
plus here.
yeah, it keeps incrementing until the length stops.
Yeah. Well, what did I do wrong?
You should put the system out of the loop.
Well, I wanted to print every element.
Oh. Initialize that.
Oh, let's say A was already initialized. This is just the loop that prints it out.
You don't increment I?
I increment it right here.
Oh. Well, okay.
Is it length minus 1?
No. Like if the length is 10, then I want it to be I less than 10 because I want to print 0, 1 up to 9.
Do you have to put like system.printout or print line string E, not just
No,
E?
it's a string. I can print a
Okay.
string like that. Well, I guess now we've eliminated just about everything.
Is there something wrong with
Yes.
it?
Okay, what is A? Is A an array or is A an array list?
it's isn't it?
Oh.
Okay, it's an array list because I'm calling get on it, right?
Yeah.
How do I get the length of an array list?
Size.
With size. Very good. Yes, so over here, it would then have to be size. Or maybe if it had been an array, then I would have had to change this thing to a bracket I. So I messed up and mixed the syntax of arrays and array lists. All right, so that was the issue here. Now, so this is the for loop that's very, very common. Every time that you want to traverse all of the elements inside an array or an array list, you write a for loop like that. And because it's so common, someone has invented a nicer way of writing the same for loop. And so you can write the exact same thing in the following way. You can say string E colon A. E. So if we look at what happens here, the system.println is the exact same thing. But what my savings now is that over here I had to explicitly get E by looking at the ith index, and I had to have an index that runs from the beginning to the end. With what's called the enhanced for loop, I don't have to worry about the index. Instead, automatically A is traversed from the beginning to the end. I don't have to worry about the beginning and the end. And in each iteration of the loop, E is set to the next element. So this thing here is set to the next element. I don't have to fetch the element, it's automatically set to it. And so you can think of this as saying, for each E in A, for each element E in A, you have to give the thing some name. Here I called it E, I could have called it X. And then inside that, there you can use the variable. So this for loop is very, very convenient. Particularly, in this very common case that you just want to traverse the array or array list. It works with arrays, it works with array lists. Unfortunately, it does not work with strings, or I would have shown it to you earlier. So should you use it? It's up to you. Mostly what people do is for the first week or two, they kind of used to this loop because you've been writing it for a couple of weeks with strings. And there's nothing wrong with using this loop for arrays and array lists. So in the first batch of homework assignments, maybe you just want to keep using the familiar one. It'll work. There's nothing wrong with it. But usually what people eventually do is they get tired of it. They get tired of writing it 100 times, and then they start thinking, can't I replace it with a nicer one? And every time that I do, I say thank you to whoever invented it, because it saved me a few keys. So I really like to use the other one whenever I can, and I think you should gradually try to move over. Not the highest priority ever, but it is something that you should eventually consider. All right. So now let's look at a couple of array algorithms that you'll find helpful for the homework. For example, finding the maximum. Now, so let me just write a function. And it turns out that it's kind of easier to write these algorithms with arrays because the notation for arrays is a little bit shorter. So I'll write it for arrays. If you ever need it for array lists, you just have to change all the brackets to gets. Let's have an array of integers. So what should I return? What type should I return? What do I write in front of the largest? So should I return a string?
Get.
Should I return a get?
Well, no, but
I should return an int because the largest of a bunch of ints is an int. So I put an int here, and to put Java happy, I have to put public, and then I want to call it from main, so I put that. So the maximum of integers is an int. There we go. All right. Now, to compute the largest of something, I need to keep track of what? So I have an array 1, 4, 9, 3, 2.
Previous one?
Yeah, the largest one I've seen so far. And so I say int largest so far. And then I have some kind of a loop. And in the loop, I say if something is greater than the largest so far, then the largest so far equals that something. And then I return the largest so far. That's kind of how we compute the maximum. And we start out, so what do I set the largest so far to start?
The first.
The first thing here. So what's that?
One.
Well, I can't say 1, right? It's not always 1.
Element 0. Element 0.
The element 0, so exactly how do I get to the 0 element?
With A and then the brackets.
Yes,
0.
A bracket 0. Excellent. Okay. Now, what kind of loop do I use? Let's
for loop.
use the, yeah, exactly, the traditional kind of for loop. For I equals I less than I plus plus. Okay. I less than what?
I plus what?
I less than what?
It's not string dot length.
A bracket size or something?
A bracket size has been proposed.
A dot length.
A dot length. And it is a dot length because first of all, it's got to be a dot because we're asking some kind of question.
Mhm.
And it just happens that for arrays you have to use length.
Because this is an array, not an array list.
That's right. Yes. For an array list, it would be a dot size with the parentheses. All right. Where do I start my I?
1.
Exactly. I start at 1 because I already looked at the 0 element. So the loop from largest and smallest, from max and min, is a little bit different. Okay. So if what is greater than the largest so far? This one. What is it? What is it? How do I get it?
Like,
So, A bracket
do you increment
A bracket I. Exactly. Okay, that's the ith element in it. So now if AI is actually larger than this, larger than the largest one I have seen, what do I set largest so far to?
I.
Do what?
Or I'm pretty sure because like
All right.
because
So
I is the integer that you're at, and then
all right. So he's so let's see what happens when I do this.
No, no,
So
no,
he
that's
sets the
wrong.
largest so far to I.
No.
All right. Let's try. Okay. So at the beginning, largest so far is A bracket 0, which is what
1.
in our example. Then I gets set to 1 over here. Then let's see, what is AI right now? You know, that's actually kind of useful to write down here for greater clarity. So if I is 1, AI is what?
1. Wait.
4.
Oh, let's write little numbers here. Always good to write little numbers.
4.
0 then?
4. 4.
All right, I is 1. What is AI?
4.
4. Is 4 greater than the largest so far? Is 4 greater than 1?
C.
Yes. And so now he says the largest so far is set to I. So now the largest so far becomes 1. 1. So he says. All right. Now I plus plus. What is A bracket 2? That's 9. Is 9 greater than 1?
Yes.
It is. So what is the largest so far set to?
2.
That doesn't make any sense. The largest that we've seen so far is 9.
That should be A bracket I.
So?
A bracket I. The largest so far equals.
So the largest so far needs to be AI. That's the value. This is a very, very common confusion, to confuse between the index value and the thing that is at the index value. I've seen that confusion a bunch of times on last Thursday and on Tuesday, when people would say, I want to know if I is a vowel. And at the time, I could say, well, I is a number. How can a number be a vowel? But when you have an array of integers, it's easier to fall into that trap because I is a number and AI is also a number. And when you confuse the two, the compiler cannot warn you. The compiler cannot know that you're on the wrong track. So you yourself have to be careful. So I is the position, AI is what's at the position. And it is such a common confusion that you really want to spot check what you're doing and make sure that you don't have that confusion. Now, using the enhanced for loop completely removes that pitfall because in the enhanced for loop there are no indexes. The confusion is because indexes are numbers, and in this case the values are also numbers. If you don't have indexes, you can't get them confused. So let's try to rewrite this loop here using the enhanced for loop. And now I wish I had a bigger blackboard. Just imagine I had a bigger blackboard. All right, so now I'm gonna write it. It's hopeless. Just put this thing into photographic memory. So now I want to rewrite the same thing. Using this loop here. So if something is greater okay, fill in the blanks.
Well, you could put E in the first one, right? Like if E is greater than
Yes.
largest so far equals A.
Yes, no?
I don't know.
Just throwing
Is
it out
A
there.
the array?
So A is in fact the entire array. So that's probably not so good.
Yeah.
Oh.
So it's just E?
Okay. It actually, when you look closely in all of these things, this value and this value is always the same, as it should be, because here we're seeing something that's bigger than the largest one so far, and now we want to make the largest so far just that thing that we've identified as the bigger one. All right, so that's all good. Now I still have to initialize the largest so far with something, just like before, and so again I start at the beginning. Now when you compare this loop here and the one on the previous slide, the one that I had to erase, there's a subtle difference between those two loops. A very small difference in behavior. It doesn't affect the outcome, but there is a small difference in behavior. How do they act differently? So I will write the previous loop here in small letters. So in the second loop, I did what? I looked at this one here and said that's the largest so far. And then I started with I at 1 and looked at these 4 elements. So this one here looked at 4 elements. The first loop here, where does it start?
Zero at the 0.
So you start with the first value?
Right, meaning the 0th value.
Yeah.
It doesn't skip the 0th value, whereas this one here did skip. So this one here skipped the initial value, and this one looks at all values. Does that change the result?
No.
In theory it might, right? Because the first loop looks at values 1, 4, 9, 3, 2. The second one only looks at 4, 9, 3, 2. It doesn't look at the 1. So it might find a different answer. But why doesn't it?
runs the smallest number in this case.
Yeah, and say we've taken A0, the first number, the zeroth number, I guess I should say. We call it largest so far. Now we're going to visit it again. We're going to visit the 1 again. I'm going to ask, is 1 bigger than 1?
No.
Which it isn't. And for the very first iteration through this loop, it'll never be true, because largest so far is the first element. Then we visit the first element again, as if we had forgotten all about it, and say, are you larger than the largest one I've seen so far? And for the first time, that answer is always going to be false. So this loop here is a tiny amount less efficient, because I'm making one comparison that's not absolutely necessary. And so for that reason, when you look at the textbook, it'll have this loop whenever you compute the maximum. But if you don't mind that one tiny little comparison, you could write it like this and it would work just as well. So I wanted to show you the contrast because it gives it, I think, a bit of a clearer idea exactly what the enhanced for loop does for you. So the good thing about the enhanced for loop is no messing with indexes. The bad thing is you're always forced to see the entire collection, even if you don't want to see them all. All right. So that's all I have for new material. Now let's go into the final part of the lab. This is lab 9. All right. So in the previous lab, you found a way of counting the number of vowel groups. You'll remember this fondly. You have here this word outrageous, for example. OU is one group, the A is a group, the EOU is one group. And we had several different ways of doing that. The algorithm that I'm showing you here is the one that's a loop in a loop. It works as follows. As soon as I find the first vowel, I increment a counter. And then if I find more vowels, I skip past them. So over here, I found a vowel, and I increment my counter, and then I skip past all the vowels. That's the inner loop here. And then the next one won't be a vowel, and eventually I find more groups. Because each time that I find one vowel, I go past all the other vowels in the group. That way I get an accurate count of the groups. All right, so now what I want you to do is modify this algorithm to find the longest of the vowel groups. In this case, what's the answer? EOU, right? So I want you to write an algorithm that, given a word like that, finds the longest vowel group. So we know there's 3, but now we don't care that there's 3. I want to instead find the longest of those groups. And all right, go for it.